really sparked a lot of conversation with our TEK experts, and then again when we started bringing the agency people out with the TEK experts, facilitated a lot of conversation and broke down a lot of walls between those two groups. And for example, this turbidity map that we created, when we were going out with them, this is actually the point all hash siphon here. And quickly, you know, we realized that that's a big issue. Where is all this fresh water that's being introduced through these diversions and these siphons? Where is it going? Where is it impacting? So we quickly realized that was a predominant issue, and we partnered with the Army Corps of Engineers, a scientist, Yvonne Allen, who was doing this turbidity frequency analysis, and we partnered with her to map this stuff. And so you map the distribution of where that fresh water is coming into the system there, and then we were able to take those maps out with us on these trips with the TEK experts to help address a lot of their issues and concerns with the fresh water and illustrate to them from a different perspective that the scientists are typically used to seeing, and now the TEK experts are used to seeing that same perspective on freshwater introduction. So it's like a common ground thing. They liked that so much that they requested one for the Davis Pond area. So from this process, we didn't go in anticipating creating this map or using this scientific data set, but through the process, the TEK experts requested that we do the same for Davis Pond, which we did, and then that facilitated more conversation over with when we were going out with the Lafitte guys, because that's where it really impacted them.
If anybody standing in the back wants to sit down, don't be bashful.
We're so non-formal. There's a whole bunch of empty spots, and we don't bite or smell.
We don't like
I think.
Speak for yourself. So, in addition to all of the TEK trips that we went out with 13 different fishermen, community members, resource users, however you like to define them, TEK experts. And in addition to that, once we had gone out with at least everyone once, we wanted to kind of test the process a little bit more and to actually have some of the interactions between the many different types of agencies that are involved in coastal restoration. So USGS, CPRA, National Marine Fisheries. I can keep on going on and take up the rest of the presentation. So what we did was we invited some key agency people to come and participate in the process, to come out on the boats, and here are a couple of examples of that interaction taking place. And kind of as Matt was just mentioning with the turbidity maps and also with being able to go out and do some of the scientific sampling, this took that knowledge transfer to another level. So here you could see where it's almost a classroom type situation on the front of Mr. Coulon's oyster lugger here. And we have, I think, 4 different agencies represented in addition to a couple of us. And it's almost like a classroom type setting where you're able to engage in a totally different atmosphere that isn't afforded in other types of interaction. And here we have a couple of examples of some of the types of just, I guess, issues and concerns that you're able to see firsthand and you know, up close. On the left here, this was a concern about a little bit too much fresh water in the pen south and east of Lafitte. And there was some fish kill going on and so much vegetation that it was making it a little bit hard to navigate. Over on the other side, we have Danny again showing us some of his oysters and the effects of some fresh water. So it gives you, affords a totally different type of interaction and discussion that you're not able to have otherwise.
Okay, so after all of this was done, we had about 120 hours of tape to transcribe, and that was a little bit of a process. So as our transcripts were completed, we started coding them, and we coded everything in Vivo 9, which is a qualitative analysis software. And we first coded everything just into categories that emerged from the data. There were 35 categories that came out. And as we started to see where things were really focused, we looked at all the 13 guys' top 5 priorities, what they spent the biggest percentage of their day talking about, and we also did word counts, and we came up from that process with a top 10 issue list. And it allowed us to do some mapping of the concepts in terms of figuring out where things go together, what information we got from the guys on the trips, which was thousands of pages of text, and to figure out how to move forward and what we were still missing. So, oh, that's fine. Okay, so as we did that, we realized that we had a few things we wanted to ask. There's Mr. Guidry right there. What that was your A+ map, remember? Oh, man. We're equal opportunity here. So, anyway, so we went and got in a room with the guys. We showed them our analysis so far. We showed them what we thought we had heard from them and checked to make sure we were correct. And then we asked them to start drawing some stuff on a map. If you were head of CPRA, what things would you do? Where would you put marsh creation? Where would you put shoreline protection? And where would you put freshwater introduction? And the reason those were the things we focused on is because those were the things that were focused on in the boat. Once that happened, they were able to draw a map, and that map, we were able to take each person's map and say, well, 3 out of 4 people want this island done, or 3 out of 4, or 4 out of 4 want to see some marsh creation between Bayou Perot and Bayou Wrigley's, or however it was. We then asked them, okay, well, why? Why do you want marsh creation here? Why do you want shoreline protection here? Why not here? And that's where they started to give us all of the logic behind what they drew. Well, you want to do marsh creation where you have something to build on top of, and you don't want to flood, you don't want to do marsh creation on top of oyster leases, or whatever the different logic was. That allowed us to build some models for each restoration issue. And we went back to the data and all the important buckets of text, and we then coded for those location factors. So we went back and coded everything, looking for how many times did a person describe this kind of logic on the boat, and how many of the 13 said it and how many times they said it. That allowed us to weight each location factor as we were mapping it. So you're going to see that map is going to make a map for each one of these things, and they're going to stack together to build a model.
Right, and like Michelle's just saying, this is how we develop what we call the logic models for each of our issues. And what you can see is that through that process, we identified these characteristics, those location factors that Michelle just referred to. And then in my mind as a GIS and a mapping guy, I'm thinking, okay, how can I best represent what those guys are saying in a map? And what data do I need to best represent that? And so things such as a land loss data set, from USGS, historical marsh vegetation type, from, NRCS or CPRA, the turbidity data, like I said, we got from Army Corps of Engineers, marsh fragmentation. Some of this we got from other agencies. Some of it we produced ourselves with the data that we had available, like marsh fragmentation, some remotely sensed image data that we acquired, and calculated vegetation characteristics. So we're getting it as good as we can get it, whether we can get it from other agencies or whether we can make it from data that we have. And we're trying to replicate these location factors the best we could. Now, you're not going to be 100% of anything, but you can try to get the best data that you can get to represent those factors. And there's always going to be new data that come out that may be better. So this process is always able to be enhanced.
And if I can just add on to that, it's important to note that we use all these scientific data sets, and I realize that the state is using lots of them already, but the way that the data was classified as preferable or not preferable, the way that it was organized was based on what the local said.
Right.
So it was data that may have been existing, but it was classified and represented in a different way than it had been, only to depict what the locals had said.
Right.
So anytime you see us showing you scientific data, it's scientific data that's painting the picture of what the locals said.
That's right. And so here's just to illustrate the process that Michelle and I just described, just a diagram here, but you get the TEK from the locals, you represent that with complementary scientific data layers, and for the parameters defined by the TEK, and then you do a standardized weighting process. We call this, it's just a big word for it, spatial multi-criteria decision analysis, but it's just basically taking the individual components and merging them together and then weighting them with what we what's known as the analytical hierarchy process, which is a way to standardize, weight, qualitative data inputs like that. And then we produce what we call our model map for each issue. So what we're going to do now is we're going to go through and we're going to show examples of actually building the logic model for the marsh creation island restoration issue. And so Michelle and I are going to walk through that, a few examples, and show you the maps that go into that multi-criteria decision analysis. And you know, we try to do this, actually, this illustrates how much of an integration this effort is, multidisciplinary effort, because we try to do this separately where, you know, we were just talking and Michelle was coding her data and I was getting the scientific data layers together. Didn't work, so we wound up, we had to be in the same room and we had to go through the coded TEK data and pick out the location factors together and then imagine how we're going to represent those in the
And the reason for that is that Matt, in his mind, he knew what scientific data was out there that could represent that. So if a guy is saying, oh, you know, you work your behind off all day trying to fix that, but you're not going to get anywhere, you know, he could say marsh fragmentation, right? Whereas I wasn't going to come up with that data set. So together between, you know, bringing both sciences together, social science and physical science, is how we were able to really code it the way we did. And it was at a table together, pencils out.
Right. So we'll just go into the first example. From the marsh creation logic model, factor 1, meaning the highest weighted factor, meaning the most TEK guys mentioned this, and they mentioned it repeatedly throughout all our TEK data. Location factor 1 became areas which have experienced land loss but still have remnant marsh to build upon are preferred for restoration. So, and here's an example of a quote that Michelle pulled from, to give you an idea of what we were translating to get this.
Yeah, so the guy said, you know, now some of your sections of land that are still there, you want to try to build land there. But stuff like this, and he's just pointing to open water, you know, this is gone, this is gone, this is gone, you'll waste your money trying to do that. And it's just too far gone. So we had maybe 15 or 20 quotes that say that same thing from almost everybody that took us out. And so then Matt was able to say, well, which data sets can I make a map to show where those places would be, where you would want to put marsh creation and where you wouldn't.
Right. And so what we were able to do with those data sets is then reclassify it, process it using GIS techniques to get it to approximate that location factor. So areas where there's been land loss, but there's still remnant marsh to build upon were the highest weighted in priority.